Hello, Algebra 1. Today we're looking at lesson 7.2, and we're graphing quadratics today, but they're in standard form. And so this is probably the trickiest one to do, basically because if there's an x term, that means that the graph has been shifted left or right. But unlike vertex form, we can't tell what it is right away. So basically, it's kind of like if you took vertex form and you took it and, as it's written here, you can tell the vertex is 3, -3. So it's been shifted right 3 and down 3, and you can see that right away. But if you were to multiply this all out, and distribute the 2, and subtract the 3, you would find out that that same equation looks a lot different. It looks a lot different. So in standard form, those transformations are hidden. And what's interesting is it's kind of a challenge to go backwards. We're going to learn how to do that at the end of the year. But it's kind of a challenge to go backwards and get back to this. And so somebody helped us out, though. Somebody figured out that if you're in standard form, you can actually find out how much it's been shifted left and right. You can find the axis of symmetry right away. So that's cool. So what you can do is use this formula right here to find out the x value of your vertex. So let's practice that. Example 1, find the axis of symmetry and the vertex. Well, here's our function. In standard form, it's got that extra x term in the middle. So yeah, you just immediately start going negative b over 2a. I like to put the negative up there with the b. And then, it's -8. So here's our b value. Here's our a value. -8 over 2 times 2. And be careful, if you put this into your calculator, you're going to have to use an extra set of parentheses around the 2 and the 2, or else won't think you're dividing by both of them. It's kind of a weird thing. But anyway, what I like to do is just go ahead and simplify this. It's 4. So -8 divided by 4 is -2. And then from there, they want us to find the vertex. So to get the vertex, we're gonna, let's write this out. Axis of symmetry, x equals -2. And if we were graphing, we would go ahead and go to the graph paper and draw a vertical line at -2. But since we're not graphing, we won't do that. But yeah, we've got our axis of symmetry. Now to find the vertex, that's the axis of symmetry, and a y value to say how much it's gone up. So we need to take that -2 and we're going to plug it in to the equation to get a y value. And class, as some of you are starting to find out, you want to be really careful with entering this into your calculator, or you can do it by hand, which oftentimes isn't too bad. I'll be kind of honest with you. Square, you got to do PEMDAS, order of operations. Square first, get 4 times 2 is 8. Multiply next. Here as well, so yeah. And pretty quickly you realize, oh yeah, this is going to be -9. So our vertex is at -2, -9. And we satisfied those 2 questions that they had for us. Well, let's put this together for graphing. So for graphing, so what we can do is basically we're going to find the vertex and then get 2 more points. But I may I don't know, we'll do it maybe a little bit differently. But yeah, we for sure want to start with our axis of symmetry, negative b over 2a. And our b value is -6. Please include the negative with it. Over 2 times a, our a value is 3. And take your time with this. You get an axis of symmetry of 1. So I go over to my graph and I immediately draw that axis of symmetry. And what I found, class, is if you don't do that, you often reflect over the y-axis, but it's not. It's going to be reflected over the axis of symmetry, which happens to be x equals 1. And now what you're going to do is you're going to have to plug 1 in. So I'm going to go ahead and make a table. You're going to substitute 1 in for x, and then get the corresponding y value. That'll be your vertex. But then you'll need 2 more points to then reflect over. So what are 2 x values that are close to 1? Well, we could do 2 and 3, which is what I'll go ahead and do. But you could also, if you need to, go the other direction and do 0 and -1. They'll get you good values either way. So then you've got to substitute it in and figure out what each of these is. And when we put the 1 in, it looks like we'll get 2 out. So that's our vertex, 1, 2. Yeah, that was our vertex right there. We'll go ahead and write it out because a lot of times they ask for it. So our vertex is 1, 2. And then we got 2 more points. So we'll plug in 2. This will be 12 minus 12. It should be 5. This will be 9 times 3 is 27 minus 18 plus 5. So let's see, that would be 9. I think it's 14. Okay, and I'm feeling pretty confident with those. And then we plot these 2 points. So 2, 5, make a dot. But class, immediately reflect it over. And then we've also got 3, 14, which is off the chart a little bit. So we'll go up here to 14 and then reflect it across. So it should be 2 over, so 2 over should be about right there. And we've got ourselves a parabola. And yeah, so class, they can ask you all sorts of questions about this, okay? One question that they ask sometimes, which I don't really find very helpful, but they might ask you to find the y-intercept. Well, the y-intercept is where does the graph cross the y-axis? And you can see pretty clearly it's at 1, 2, 3, 4, 5, y equals 5. So you can look at the graph and get the y-intercept. But what's cool about standard form is the y-intercept's always where x's value is 0. So if you plug in 0 up here, you're going to be left with 5. So the constant is always your y-intercept. And then also, they could ask you about transformations. So I go up here first and I see that it's a vertical stretch by a factor of 3. But then for the translations, everybody, you're gonna look over here and see that it's translated right 1 and up 2, because you can't tell that from standard form. You can't tell that, not like you can with vertex form. So yeah, they could ask you about transformations. They could also ask you about domain and range. So let's do that. Domain and range. Because these arrows continue to go outward, it'll get steeper, but it will continue going outward forever. We've learned that with interval notation, we can write negative infinity to infinity. If you're not using interval notation, you would say all real numbers is your domain, your x values. Now your y values, they do extend forever upward, but they don't extend forever downward. And you always want to start with the lowest amount when you're doing interval notation. So the lowest amount is 2 for our y values. So, and you can actually stand on 2, so we block it in with a bracket. And then the upper limit is infinity. Now you could also say y is greater than or equal to 2. You could also do it that way. Well, let's flip it over, see what other problems we have to look at here. Oh yeah, so we've already talked about this. Minimum and maximum values. So yeah, class, basically it's saying, hey, if the number out front is less than 0, it's going to be, now technically it's the absolute value of it is less than 0, so it's a fraction that's less than 1. Oh, actually, I'm thinking of a vertical stretch and a shrink. I'm so sorry. If a is less than 0, I'm getting totally confused there. But if a is negative out front, it's going to open down. It's going to be flipped over the x-axis. I totally got confused there. It's going to be flipped over the x-axis, and you're going to have a maximum value, and it's going to be the y value of your vertex. So if it happens to be at 5 here, the maximum value would be y equals 5. And then if the a value is greater than 0, so it's positive, then it's going to open up. It's not going to be reflected. It opens up, and you've got a minimum value, kind of like the bottom of the pool sort of thing. And that might be at like y equals -6 or somewhere like that. But we've talked about that already. And then, for example, 4, we're graphing again. Oh, no, we're not graphing. They're wanting us to practice finding the minimum and maximum value. So class, the minimum and maximum value is going to be the y value of your vertex. So to do this, we're going to have to do axis of symmetry first, -b over 2a and then that tells you where your maximum or minimum value is. Then you plug it in to find out what that value is. So I guess I'll use function notation. That's kind of fun. So the function's value at -3 is going to be -4 times -3 squared minus 24 times -3 minus 19. And yeah, I would totally get it if you grabbed a calculator for this and punched it in. But you could do it by hand and just take your time with it. But I got 17. So the function's value at -3 is 17. Now class, that's our answer, but here's the thing. Is it for a minimum or is that a maximum? Well, it depends on if it opens up or down. Because it has a negative out front, it opens down. So that means if it's opening down, this is a maximum value. So maximum value of 17. All right, let's get back to graphing here. Let's graph this. So we're gonna, as soon as we see its standard form, immediately do x equals -b over 2. Oh, and check it out. Our a is 1 because there's a coefficient of 1 hidden there. And then take your time with it. 8 over 2, which is 4. So our axis of symmetry is 4. Go over 4. Vertical line. Axis of symmetry at x equals 4. And that's our A of S. A of S. And then class, I like to go ahead and make a table. Since we're at 4, we're going to need to plug 4 in and find out what the vertex is. So that's what we're going to do there. So yeah, we'll go 4 squared minus 8 times 4 plus 7. We're going to figure that out. But we're also going to need to get 2 more points. And I'd probably use 3 and 2. I like to use smaller numbers rather than bigger numbers. So we'll use 3 and 2. You could also do 5 and 6. You'll get the same answers out. So yeah, we're gonna have to plug in, substitute in 3 squared. And like I've been saying, take your time with these. Yet enter it in really carefully, or work it out by hand. But yeah, I ended up getting a negative, let's see here. I ended up getting a negative 9 for that one. So 16 minus 32 is negative 16. Yeah, plus 7 is negative 9. And then I ended up getting a negative 8 and a negative 5 when I punched those into my calculator. So yeah, so now we plot these points. 4, negative 9 is our vertex. 4, negative 9 is the vertex. 3, negative 8 is an extra point. We're going to reflect it over. 2, negative 5 is another point. Notice it's 2 away, so we go to the other side. And we have our parabola. So class, they also wanted us to find the axis of symmetry, which we did. They also wanted us to find the vertex, which we did to graph it. Now class, does this open up or down? It opens up. So we're gonna have a minimum value, and our minimum value is y equals negative 9 is our minimum value right there. And then also they wanted the y-intercept. Well class, I didn't graph mine crossing. So, and I would just really be guessing unless I actually plugged in more points. But the nice thing is it's the constant right here. If we put 0 in, we're gonna get 7. So the y-intercept is 7. It's not really that helpful. And then the domain and range. So we've got our domain, all real numbers, negative infinity to infinity if you'd rather. And our range, our smallest value is negative 9. And our biggest value is infinity, like so. All right, so class, hopefully you're realizing that graphing in standard form isn't that difficult. It's got a lot of similarities with vertex form. But a little bit of practice, I think you'll have it down pretty good. Take your time when you're doing your calculations. Have a good day.